So last time we stopped at test for reliability. Tests for reliability. In other words, some people prefer to call them reliability tests. Reliability tests. And these reliability tests, as we said the other day, they are tests that are about confirming the accuracy of the equation and how you can be able to depend on this relationship. The tests are divided into 3 areas, as you can see in your notes. And because you already have the notes, I will be discussing a test, and then we look at the question at hand, then we write about it, what pertains to the question, because you already have the notes. So as you can see in your notes, the first test is called economic plausibility. It's called economic plausibility test. It's called economic plausibility test. Economic plausibility test. You can just write as I'm writing, then I'll be directing you what to write, what not to. Now, when we talk about economic plausibility, what I'm writing here now is not for you to write, because it's already in the notes. I'm discussing the notes, we shall go back there. Economic plausibility is a test that is done to confirm 2 things. The first thing is called logical defensibility. Logical defensibility. And the second thing is called economic sense. So when we say we are doing economic plausibility, we are testing whether the observed relationship is logically defensible and is making economic sense. Now, a relationship is logically defensible if it remains unchanged. If it remains unchanged, even as circumstances change. Now, for human beings, we talk of circumstances, we talk of situations. And our relationships are within those circumstances and situations, or what people would call seasons. But for data, we talk of samples. Now, going back to the issue of relationship with human beings, we know a very good case when it comes to marriage and people are being joined together in church. They are told to tell each other that I will love you in times of good health, in times of bad health. I will love you in times of riches, in times of poverty, and so on. So they are promising each other that our love will remain even as circumstances change. Now, that kind of a relationship is called logical defensible. And anyone would be willing to commit themselves to that kind of a relationship. But if someone was to come and tell you, mimi nitakupenda as long as you have money, as long as you are healthy, as long as you are this and you are not this. Now, that kind of a relationship you will not be willing to commit yourself to. It is not logically defensible. The relationship is said to make economic sense if it is in agreement with what would be expected. There is always what we expect. For example, here and now, as I teach you, I believe you expect that I am qualified to teach this unit. I have been to class or I have sat for the exam and I have some experience. That is your expectation. But if you are to do some further investigations and you seek to know how long I have taught, where I schooled, whether I sat for the exams or not, if you confirm for sure that I have sat for the exams and I have passed, I have some experience, then what you are expecting will agree with what you have found out. But if you find that I never went to school, I have never sat CASNEB exam for AMA, I have never taught any other class, then what you will find out or what you have found will be different from what you are expecting. Now, that kind of a relationship is said to be illogical. It's not making economic sense. So, in our case here, we developed an equation which was found to be y is equals to, everybody me what were the values? The value for A.
622.43.
622.43 plus
4.43x.
4.43x. Good. Now, this is what we found out when we did an investigation between the electricity expense in the company and the machine hours. That is what we found out. And this was found out after we analyzed 12 observations. So if we were to go back to the same company and take another set of 12 or another set of 20 or another set of 15 or whatever number, and for each set we run an equation, and each of those various sets gives us exactly these values, then that relationship will be said to make economic, will be said to be defensible. Now, unfortunately, in our case here, we are not able to go back to the company where this data was obtained, so we cannot run the test of defensibility. But we can run the test of economic sense. Now, in our notes, we have said there are 3 types of relationships. The first relationship is called direct relationship. And direct relationship is represented by positive sign. And it means that positive sign of the slope. And it means that as the value of x changes, y will also change towards the same direction. Will change towards the same direction. The other one is inverse, which is represented by negative. Now that means that as the value of x changes, y will change towards opposite directions. Opposite directions. And then we have what we call the null relationship, which is represented by 0. What that means is that the change in x has no effect on the values of y. Change in x has no effect on the values of y. Now, in our case here, we have machine hours and we have the amount of money paid for electricity. From what you would expect generally, would you expect a null relationship or a direct or an inverse? What kind of a relationship would you expect?
Come again?
I'm asking if the machine hours are increasing, do you expect the electricity expense to increase also or to come down?
To increase.
Good. To increase. That means we expect a positive relationship. And that is what we can see here. So now let's go back here and write the following. Right. The relationship in the above case, is making economic sense. Is making economic sense. That is plausible. Making economic sense. That is plausible. This is because we have observed a direct relationship. We have observed a direct relationship, and you can put into brackets positive 4.43, a direct relationship between machine hours between machine hours and electricity expense, which agrees with our expectation, of a direct relationship, Full stop. So is that okay?
Yes.
Yeah, so if you come across a question and they tell you to do an economic plausibility test, you simply check what you have observed, you compare with what you are expecting. If they are in agreement, then it is plausible because but if they disagree, then it is not making sense. That's why you hear even when people are talking, na unaambiwa ka story that you are not expecting ikuwe namna hiyo, unasikia mtu akisema I can't believe, I can't understand what you're saying. The reason why you are not understanding quickly is because what you are hearing is not what you are expecting. What you are hearing is not what you are expecting. But if what you are hearing is what you are expecting, it becomes very easy for the one telling you the story. Now, hey, I expected it that way. Let's go to the second category. The second category is called goodness of faith tests. That is B, goodness of faith tests. Goodness of faith tests. Now, these goodness of faith tests, there are 6 of them, and they are tests that we do to confirm that the data fits the equation from, or the equation fits the data from which it was derived. For example, when someone calls you, let me use a case of someone calls you from Equity Bank and they start asking you some information. It is important before you release the information, you check whether the person fits Equity Bank. You want to confirm whether they actually come from Equity Bank or they come from Safaricom or any other place. So you subject them through tests by asking them the questions, umepata majina yangu wapi, umepata namba yangu wapi, mbona usifanye hiyo kitu unaniambia huko, when did we meet? So you start asking the questions so that you are able to confirm that for sure this person that I'm dealing with fits the data. Now what happens in consultancy cases, a customer gives you their data, like the data in the and they tell you develop a relationship between machine hours and electricity expense, a relationship that will help us to be predictive. Now it is expected ukishapewa hiyo data, you will go and take your time and develop a good equation. Ufanye ile kazi yote tulifanya hapa. And then you come and make the presentation. That is what we expect. But unfortunately, there are some guys who are, let me say, they are greedy, they are crafty. They will not do that. They will go take their good time, then cook the figures, and then on the day of presentation, they come and tell you, we have burnt the midnight oil, and this is how your function is. Now, your function, utakuwa unajaribu kuitumia, and it will be giving you completely different figures. Simply because that function was not derived from the data. So when the consultant has brought the model, before you use it, it is good to confirm that the model comes from that data. So it can be done through visual inspection, we'll be doing that. It can also be done through functions, through some tests, which we are going to go through. So there are 6 of them, and the first one is called coefficient of determination. Coefficient of determination. That's like I'm writing. Coefficient of determination R square. Coefficient of determination R square. Now, this coefficient of determination, it simply shows how well X explains Y. If you are in a relationship with a person, we expect you to be able to explain that person. Unaweza tuambia mambo ya huyo mtu. You can tell us their names, where they work, where they come from, what they like, what they don't like. You can be able to give us some information, although not all, because no one knows another person 100%. It's only God knows. But at least we expect you to know some information. Yeah? If right now you have some people, and I believe you have some people you have some relationships with, whatever kind of a relationship, both at work, both at home, and whatever. Right now, those people who are very close to you, if we were to ask them where you are, I expect them, they know that most likely you are in class. Is that so?
Yes.
Yeah. But ukiniambia huyu mtu ni rafiki yako wa karibu, your best friend, na saa hii nimpigie simu nimuulize uko wapi, aniambie maybe uko somewhere like in Nairobi ama Meru, and you are in class in Thika, that will leave a lot to be desired. Is that so?
Sure.
Yes. So how well you can explain, it shows how strong the relationship is. So that one is measured using R square. And as you can see in the notes, we normally recommend any relationship that you can be able to explain 80% or more, it is good you get into that relationship. That's why it's always important to take time before you say yes or before you say no. Gather information so that you can be able to explain at least 80%. You useme yes ama useme no in whatever kind of a relationship, whatever kind of a relationship. And we do not go for 100% because you cannot know a person 100%. Like now, when I'm in this class, my wife already knows that I'm at the workplace, I'm supposed to be in class, but she cannot confirm for sure that right now I'm in class. Is that so?
Sure.
Yeah. The same thing applies to you. Yeah. Actually, unaweza kuwa mmekaa na mtu in a very close distance, but you cannot tell what they are thinking. Yeah, you can't tell. You cannot tell what is in their heart, but at least 80%. If a relationship is below 60%, kama hujui kitu ama mtu 60%, that one you should not commit yourself. You should not. Hata kama ni biashara, you want to start a particular business and you don't understand that business up to 60%, don't invest there. Wait until you build some knowledge. Kama ni mtu you want to engage with, don't engage until you get at least 60%. Now, between 60 and 80, we say there now you can take your chances. You can take the risk. But if you have 80, now it's good to go. But we are not even saying, in any way saying that if it is above 80, it cannot fail to work. There are many that have still failed, but at least to be on the safe side, it is recommended that you get to 80%. Neither have I said that any relationship that is below 60 cannot work in the long run. We have seen many people who met just for 1 or 2 days and they got into very serious relationships that have lasted for long. Yeah, but to be on the safe side, kama haijafika 60, be very careful. Kama imefika 80, it is recommended we go on. Now, in this coefficient of determination, the computations are, so we have the value here. So just put them like I'm putting. So we have the value. R square is given as sum of y predicted minus y bar. You square this, you divide by sum of y minus y bar, you square, multiply by 100. So I want you to give me this figure. Go to the column that we had y predicted minus y bar. You give me the total of that column.
What?
Y predicted, yn minus y bar squared. The total of that figure, the total of that column. Can you see it? Y predicted. Minus y bar. 22, 6 or 7. 6 or 7. 0.8851. Minus y minus y bar. $85,950 is the figure you had confirmed. Or whether you confirmed and got a different value or it's just like that. What is the answer?
$26.30.
26.3%. 26.3%. So if that is the value that we have gotten, then katika hapo chini interpretation. Interpretation or the comment. Utaandika, this shows that 26.3% of changes in electricity expense is explained in brackets cost or brought about by, explained by machine hours. This shows that 26.3% of changes in electricity expense is explained or caused by machine hours. The relationship is too weak to be accepted. As a forecasting model or as a forecasting tool. It is very, very weak. Because you can see it is just 26. So it is not helping us so much. It's only helping us to know 26% of our expenses. So it's not something that you can rely on. So that is how the coefficient of determination is interpreted. Are we okay with that?
Yes.
Good. The next, number 2, is called standard error of estimate. Number 2 is called standard error of estimate. Normally denoted as SE, as you can see in the equation, or rather in the notes, standard error of estimate. Now, this standard error of estimate, it shows us the amount of error you can make after relying on this model to predict. Just like I told you, the fact that tumesema 80% is good to accept does not mean you will always get it right. There are instances you will get it wrong. As in, what you expected or what you predicted will be different from what you actually get. You always get it wrong. Or rather, there are times you get it wrong. So how wrong or how the size of that error is measured using this. And obviously, the smaller the error, the better the equation. The smaller the error, the better the equation. Now, in this case, the SE, we can talk of the value. We can talk of the value. Tutasema value. So value for this is, the formula is SE is equal to sum of y minus y predicted squared. You divide by n minus k, then you get the square root. You get the square root. So when you look at your notes, the table that we have drawn, if you got y minus y predicted squared, I'm getting 69,155.4351. You divide by n. N is 12, the number of items. And K is the values we computed. Those values of A and B, they are the ones we call K. So there are 2 of them. We computed A and we computed B. So K is 2. K is 2, as you can see in the notes. So work on that. the answer?
6,915.543.
Even after getting the square root? It should be
Yeah.
9,155.4351 divided by 10 is 6,000. Get the square root of that answer.
Oh, we are getting the square root.
Yes, 83.16. Is that confirmed?
Yes.
Okay, then down there we write that still down there we are still writing this. So the next thing is forecast. Now forecast, why predicted? Our equation, or I have it here. Our equation was 622.43 plus 443x. That is the equation. So can you give me a figure for machine hours? Give me an arbitral figure. So that we say when X is how many hours? Give me a figure from whatever, from the Bruce.
15.
So when X is 15, Y predicted will be 622.43 plus 4.43 times 15. So that one has been assumed, but if it was a question in the exam, they would have given you the figure. So 622.43 plus 4.43 times 15. Tell me whether you're getting 688.88.
Yes.
Good. So that is now what has been predicted using this function. So the next thing that we want to do or should be done as we look for the error, it is now interval estimate. Interval estimate. Interval estimate. We want to see what will be the interval estimate. We are still under the standard error of estimate. The interval estimate is usually given as y predicted plus or minus t 1 minus alpha out of 2 n minus k, those are the degrees of freedom. You multiply by SE. Multiply by SE. Multiplied by SE. So at 95% confidence level, at 95% confidence level, at 95% confidence level, our predicted is 688.88 plus or minus t 1 minus 0.05 out of 2. Now, just to remind you, this alpha, it is what remains for the confidence level to be 100%. It is what remains for the confidence level to be 100%. So when you're told 95%, then we have 0.05. Then we have 12 minus 2. You multiply by the standard error of estimate, which was 83.16. 83.16. 3.16. So we are going to go to the tables. If you look at your past papers, huko mwisho, you will get the students' T tables. Have you seen it? Imeandikwa students' T distribution.
Yes.
Haya, sasa kama umeiona, maybe come here. It is this one. So we start from here.
Yes.
When you are here, because of that 2, so now our formula is divided by 2. So you go to the line that is written two-tail confidence level. Two-tail. Then you move towards the left and stop at where there is 95%. When you are there, you move now downwards and stop at 10, where there is 10. So nisomee what you can see there.
2.2281.
2.2281, good. Now that 10 is this one. 12 minus 2 is 10. Then the 95 is this one, which is also here. So if that is true, then we proceed and say 688.88 plus or minus 2.2281, you multiply by 83.16. So this goes on to become 688.88 plus or minus 2.2281 times 83.16. We have 185.29. Then you say 688.88 minus 185.29 is 503.59. This is our predicted value. And on the upper side, 688.88 plus 185.29 is 874.17. Are you through up to that point?
Yeah, that's what I'm lighting.
Okay.
I'm through.
Good. Now, just to try and interpret again, or to take you through again, what we are saying is using a function that was derived as 622.43 plus 4.43x. That is the equation we began with. When we are told that our machine will use 15 hours, then we expect electricity cost to be 688.88. So kama unataka kutumia mashine yako for 15 hours, then you should have this money to pay for power. But because of the possibilities of errors here and there, we are 95% sure that even if we don't get 688 and we get something small, this is how low it can go. Tukilipa kidogo sana ni 503. And for some reasons, ikisonga juu, it will stop at 874. So if you are the owner of that company, then you will prepare your budget to have a maximum of 874 in the event that wataenda whatever. But when you are giving your accountant the money, you can first of all give them 503. Waambie wangangane kabisa waone kama watatumia 503. Wakishindwa kutumia 503, then you can give them additional because you are already prepared that kama si 5 or 3 itasonga, lakini haistahili kupita hapa. And in the event wapitishe hapa ama watumie less than this, you should also go and check, because using less does not mean they have done well. Ni kama saa hii nikwambie next week ndio tunamaliza syllabus. Now, having taught you 2 or 3 weeks, it is something that should be desired. Have we covered everything? Yeah. So the fact that someone has done within a shorter time is something that should be investigated. Equally, if I tell you hii syllabus tutamaliza May next year, again, that should be investigated, because we expect tumalize mapema, but kama tutachelewa by November mwisho tukuwe tumemaliza, because the exam is in December. So the latest we should go is November. So that is how you gauge, and even later on as you discover, as you go discussing other topics, unatumia this information to judge performance, to know whether you shall renew the contract or you shall not renew. Is that fine?
Yes.
So now to test number 3. Test number 3, which is called F-test. F-test. That's number 3 now. Now, when you are in a relationship, it is always very, very important to know the kind of importance the other person has attached to that relationship. It is what in the streets people will say, I want to know whether that person takes me as a priority or they take me as an option to them, as any other option. Now, for you to know that, we do an F-test to know how significant am I to the other person that I'm in a relationship with. There are many indicators that will show that, but one of them is F-test. So we do a hypothesis test, and this is how it's done. So the first thing, we do hypothesis. The hypothesis. By the way, did you do quantitative analysis?
Yeah, I did it in section 4.
Oh, good. Najua kuna wengine ninafunza siku hizi hawakufanya quantitative analysis, walipata include sec 2. So kama ulifanya quantitative analysis, then this language is not new, still.
Yes.
Yeah, so if it's not new, that's very good. So in the hypothesis, then as you should know or should remember, we start with the null hypothesis, H0. And this one is normally written as the relationship is not significant. The relationship is not significant. That is how we write the null hypothesis. The relationship is not significant. Then we do the alternative hypothesis, where we say the relationship is significant. The relationship is significant. The relationship is significant. That is the first step. The second step, we call it significance level. We call it significance level. Significance level. Now, significance level, this one we can assume, so we will say let alpha to be 0.05. So we are going to assume that alpha is 0.05, but if it was a normal exam, they would have given you that. The next thing is called test statistic. It's called test statistic. Test statistic. So test statistic, F is given as R squared, which is divided by K minus 1. Then you divide this by 1 minus R squared. You divide it by N minus K. n minus k. So f calculated, I think we have just computed the value of r squared, kapata 26.3. Is that so?
Yes.
So this will be 0.263 divided by 2 minus 1. I've just told you that k is 2. This one divided by 1 minus 0.263. You divide by 10 minus 2. 10 minus 2. So work out that as I put some more ink on my pen. Give me the answer.
2.8548.
2.8548. Good. To enter now to the next step, which is called decision rule. Decision rule. And in this decision rule, we draw something like this, as like a small table. This is called x-axis. This is called y-axis. Then we have something like this here. Then here we say reject null. Then here we will say accept null. And then in this decision rule, we normally say numerator degrees of freedom is 1. Denominator degrees of freedom is 10. And then alpha is 0.05. That one you already said. So just get to that point, then I will explain as we move. So here it's called F critical.
I'm through.
Good. So these ones, I'm calling them numerator degrees, and the numerator degrees of freedom, they are these ones that you can see here, the numerator, 2 minus 1. is how I'm getting that one. Then the DTF means denominator decrease. So denominator, it is this one, 10 minus 2, which is, sorry. Hey. This one was supposed to be 12. So I wrote the answer instead. Let's rectify that.
Okay.
Let's rectify this. It's supposed to be 12 minus 2, which is supposed to give us 10. So I wrote the answer instead of, so it's supposed to be 1 minus 0.263 divided by 10. Multiplied by 0.263. Yeah, I'm getting 3.56. 3.5685. Is that okay?
Yes.
Let's now go back to the tables. Huko nyumba mahali kuna tables. I think they should be the very last ones, the very last page of your class papers. The second last page. Have you seen it?
Yes.
Now kuna mahali wameandika degrees of freedom N1. Hizo N1 ndio numerator. Na hizi zinateremka ndio denominator N2. So tutaenda kwa column 1 because our numerator is 1 and row number 10. So read for me what is there. Column 1, row number 10. What can you see there?
Uh, 254.30.
Sorry, umesema aje? Umesema row number 1 or sorry, I was supposed to say column number 1. Column.
Okay.
1, because that is where we have the numerator. And then number 10. Column na row. So column 1, row 10.
4.96.
Good. 4.96. That's how it's supposed to be. So here we are going to. So once you write that way, we proceed to the next step, which is called conclusion. Conclusion. Now, conclusion is you simply check this one against this. And as you can see, this one is on the lower side because it is 4. And the lower side says we accept null. So we are going to say accept null hypothesis. Accept null hypothesis since F calculated is less than F critical. Since F calculated is less than F critical. That is 3.5685 is less than 4.96. It's less than 4.96. So that is the conclusion. Then we need to make the meaning. The meaning. The meaning of that is, remember our hypothesis here was, the null hypothesis was the relationship is not significant. So now that tumekubali tasema the relationship between electricity expense and machine hours in the above case is not significant. The relationship between electricity expense and machine hours in the above case is not significant. What that means is that it's not very important in the streets when people are in relationships. You hear them say, I'm in a relationship, but it's not a serious one. So when someone is telling you it's not a serious one, it is telling you they are still open for any other that can come. But when someone tells you, I'm in a serious relationship, or I'm in a significant relationship, it tells you they are already satisfied and they are not open for any new relationship. Or if they say the relationship is not serious, it means si kitu naweza rely nayo. Even when it comes to job, you will hear people say, I'm working somewhere, but it's not a serious job. So it's not something I can rely on. But when someone tells you I'm working and the job is serious, it tells you they are comfortable, they can rely on that job, and they're not looking for another. So that's what we call a test. Are we okay at that point?
Yeah, we're okay.
Good. So we now go to test number 4, which is called correlation coefficient. Correlation coefficient. Correlation coefficient is normally given as R. Some people call it multiple R. Multiple R, capital R. Correlation coefficients are, you can also call it multiple R. Multiple R. So this one, it is simply used to study 2 things. One is the strength of the relationship, and number 2, the nature of the relationship. Hii haina mambo mingi. So straight on, we shall write value. Now the value for this R is given as the R squared, you get the square root. So it will be the square root of 263, obviously after the decimal. So if you are told to get the square root of 0.263, tell me whether you are getting 0.51.
Yes.
Good. 0.51. That is the value. So if they told you to interpret, what does that mean? You are told to interpret the meaning of that. Interpretation or the meaning or the comment, either can do the interpretation. The interpretation, this shows existence of a direct average relationship. A direct average relationship. Direct average relationship between electricity expense and machine hours in the above case. Machine hours in the above case. Machine hours in the above case. Okay, so we are calling it average because you can see it's around 50%. So iko hapo katikati, the average. See, too weak, it's not too strong. And from the test you have done, you can see this relationship is failing. Tangu kwa R squared, tulisema is not explaining. Then tumekuja kwa F, haijapatikana ikiwa significant. Then tumekuja hapa kwa R, bado tunasema ni average. So it's not something you can rely on. And something else that you should also be able to get here is before you say yes or you say no, do many tests. Don't just rely on one. Don't rely on one. Don't do one test, ikikuwa positive, unasema yes. Ama ikikuwa negative, unasema no. Subject that person, subject that relationship into very many tests. And when you subject them into very many tests, you'll be able to see kama kuna kitu imejificha. Lakini ukirely on one, chances are there are other underlying things you may not be able to discover. Okay. The next one, number 5. Test number 5 is called standard error. Standard error for the slope. Standard error for the slope, SB. Standard error for the slope, SB. And that standard error for the slope, SB, it is the one that shows us the amount of error that is contained in the value for the slope. Shows us the amount of error that is contained in the amount for the slope. So just like we said with the standard error for the standard error for the estimate, the smaller the value of the error, the better. So let's get the value. The value SB is normally given as SE. You divide by the root of the sum of x minus x bar squared. SE divide by the sum of x minus x bar squared. Now remind me what we had gotten as SE. It was 83 point what?
3.16.
Good. 3.16. Then go to the table that we had drawn in the column of x minus x bar, and you realize that the total was 1152. So we get the square root of that. The square root of 1152. So we are saying 83.16 divided by the square root of 1152. Tell me the answer.
2.45.
Good, 2.45. So that is the error that is contained. That is the error that is contained. So if that is the error that is contained, as usual, we normally want to work with interval estimation, so we can get the interval estimate. The interval estimate. And this one, the formula says B plus or minus T 1 minus alpha out of 2 n minus 1. N minus 1. Normally use 1. Then you multiply by SB. Multiply by SB. So at 95% confidence level, B, our slope, kutoka ile function tulikuwa nayo, it was 4.43. So plus or minus T, 1 minus 0.05 out of 2. N is 12, so 12 minus 1. You multiply by SB, tumepata ni 2.45. 2.45. So 4.43 plus or minus Nataka tuende kwa t-table. T-table. Again, we shall go to two-tail confidence, lakini saa hii tutateremka kwa namba 11. Teremka kwa namba 11, not 10.
2.2010.
Good. 2.2010. So we multiply by 2.45. So in that case, it is 4.43 plus or minus 2.201 times 2.45 is 5.39. So if you subtract 4.43 minus 5.39, you work with a negative 0.96. This is B. And then 4.43 plus 5.39 is 9.82. Are we okay with that?
Yeah, I'm good.
Yeah, so if they were to ask you to tell them the confidence interval for the slope, hii value tulikuwa tumepata kwa ile table at 95%, that is the safari you take to come to these destinations. Haya, kama tuko sawa up to that point, safari mrefu inaendelea. Test number 6 is called t-test. It's called t-test. Now, t-test, it is used to show how significant x is as a predictor of y. As in, when you look at x, can you be able to know y? I'm sure umewahi in a relationship, some people being very close, that when you see one walking around here, you can almost be sure the other one is just around the corner. So you can use that one to predict about the other one. And equally, we also have seen some relationships where looking at one person, you cannot tell about the other one. Not that there is no relationship, but the style, the way they do it. So we want to see how strong, or can we use X to tell about Y? So again, we do a hypothesis test, and the steps taken are, number 1, you do hypothesis. And in the hypothesis, H0, we normally say X is not a significant determinant of Y. Determinant of Y. X is not a significant determinant of Y. Then when we come to HA, say X is a significant determinant. Significant determinant of Y. In other words, it is something that you can be able to rely on to tell the values of Y. Step number 2 is called significance level. Significance level. Now, significance level, we normally say let X to be equal to 0.05. Let X to be equal to 0.05. The next one is test statistic. Test statistic. Now, in the test statistic, T is given as B, you divide by SB. B, you divide by SB. So our T calculated will be 4.43, which is divided by 2.45. 4.43 you divide by 2.45. So 4.43 divided by 2.45. What are you get?
1.81.
Okay, 1.808 or 81. And use 3 decimals. Aya, kutoka hapo, the next step inakuanga decision rule. Decision rule. And this decision rule is what we call two tails. Two tails meaning we are shading both sides. And then the degrees of freedom. The degrees of freedom are 12 minus 1, which is 11. The degrees of freedom are 12 minus 1. So, Tachora, something that looks this way. And we divide here, here, and it says something like this. So here we will say reject null, and this is 0.025. Now 0.025 comes from this 0.5. This one, when it's divided by 2, because we are doing two tails. If you are in between here, we say you accept null. You accept null, which is 95%, 0.95. And then if you are here, we will say you reject null, which is 0.025. And this one is positive T critical. And this one is negative T critical. And this is the same value to tumesoma kwa table sahihi. This one, 2.201. So it's negative 2.201. This one is positive 2.201. 2.201. So once you finish drawing, let me know.
I'm through.
Good. So if you are through, we can proceed and make our into a conclusion. Into a conclusion. So conclusion, you simply check this one. where it is within this range. And you can see iko hapa katikati 1.8 iko hapa. So that means we will accept null hypothesis since minus T critical is less than T calculated, which is less than positive T critical. Minus T critical is less than T calculated, which is also less than positive T critical. That is minus 2.201 is smaller than 1.808, which is smaller than positive 2.201. Positive 2.201. So the meaning of that is machine hours are not a significant determinant of electricity expense in the above case. Machine hours are not a significant determinant of electricity expense in the above case. So you cannot rely on them. That is what you mean. You rely on them to predict. You will always be getting it wrong. So are we okay?
Yes.
Good. So those are the 6 tests, what we have called the goodness of faith. Goodness of faith. Now from there, we go to the third category of tests. The third category, C, which is called regression assumptions. Regression assumptions, or the assumptions used in regression analysis. Regression assumptions. Now, as you can see in the notes, an assumption is simply a condition that must be met in order for certain results to be achieved. It's a condition that must be met in order for certain results to be met. And when you violate those assumptions, the results will not be as per the expectations. So in any forecasting endeavor, it is always important to take time and confirm whether the preconditions, the assumptions have been maintained. So we have 6 of them, and as you can see in the notes, they are well explained. So what I will do in our case here, I will just be summarizing, but in your notes they are there in full. So the first one is called linearity. Linearity assumption. Now, linearity assumption, it has been described in your notes, and it simply means that the relationship between X and Y is linear. can be expressed in the form of y is equals to a plus bx. And specifically, it shows a straight line when it is plotted. So there are two ways, at least two ways we use to confirm this. The first way is you plot a graph. And when you plot the values of x and y, if you see a straight pattern, that tells you the relationship is linear. But if you see a nonlinear, a pattern that is not straight, that tells you linearity has been violated. Linearity has been violated. So what we are going to do in our case is to use the second method, which requires you develop the equation and then you confirm whether it takes the shape of y is equals to a plus bx. Because now here we cannot plot. So in our notes, utaandika hivi. The relationship between machine hours and electricity expenses in the above case is linear. That's the first point. The relationship between machine hours and electricity expenses in the above case is linear. Why is it linear? This is because the equation obtained, comma, y is equals to 622.43 plus 4.43x, comma, is of the form y is equals to a plus bx. That's how you make the comment. You tell us whether it is linear or not, and if yes, even if no, you should tell us why. So this one is linear because what we got this one inafanana na hii general format. Na hii ndio general format ya a linear function. So that one is as simple as that. Let us go to the second assumption. The second assumption, number 2, is called zero mean. Zero mean assumption. So if you can check in your notes, you see that we normally call it the zero mean for the error terms. But as I've said, now that we already have the full notes, we're just making brief notes. So what this says is that the error terms should have a mean of 0. So in this case, we will need to get the value. So how do we get the value? E bar is given as the sum of the EIs. You divide by n. I don't know whether we say the one that we called the error values in our table, the error values. I want you to read for me what we have gotten as the total for the error value. Those are the EIs. What did we get?
The standard error.
Abana, in the table ya illustration, ile table tulichora ilikuwa na 11 columns. One of them tuliita error value.
Error value. Yeah? Negative 0.06. Negative 0.06.
The total error values.
Okay.
Ile table kubwa tulichora ilikuwa na 11 columns. Kuna column hapo somewhere katikati tuliita error values. Y minus Y predicted.
Oh, 45.14.
Good. 45.14. Hizo ndio zinaitwa errors. So you divide this by 12. So if you get all after one. Okay, so if you get that 45.14 divided by 12, you getting 3.76.
Yes.
Yeah. So once you get 3.76, if you compare with the electricity expenses, now look at the column here, electricity expenses. Are you there?
Yes.
Now you got the 960 all the way back at 1020.
Yes.
So what you need to ask yourself is, if we are making an error of 3.76, is it significant? You can answer that subjectively, useme hii ni kidogo sana. Ama if you want to be objective, you do a hypothesis test like we have done. Okay, others, you confirm whether it is different from 0 or not.
Yes.
So the comment we can make is 3.76 can be taken as 0 or insignificant. Can be taken as 0 or insignificant when subjectively compared with the values of y. The values of y in this case. We always say in this case because it's not a general rule. The beginning utapata 3 is significant. So it's for this case. And the inclusion of the word subjective means tumetumia macho tu kuangalia. This is tumejudge. But if you want to be objective, na usiulizwe swali na mtu, you just do a hypothesis test. Once you go for hypothesis, you come all the way to the meaning. So either is acceptable depending on the levels of accuracy that you desire. Let us go to the next one. The next assumption, number 3, we call it constant variance. Constant variance assumption. Constant variance assumption. Constant variance assumption. What this means is that the values of the errors do not depend on the values of x. Do not depend, and that data is good. So this one we are going to do, it is done in 2 ways. You can do visual inspection, kuangalia kwa macho, like I want us to do, ama you can draw something we call polygon or polygon curve. And when you do that curve, you are able to tell whether they are depending or not. So nataka tuangalie hii. You you can see the first value. Are you back to the table?
Yes.
You can see the first value is 960. What's that one? We are using the values of x. So the first value of x is 51. Now you're 51.
Yes.
Ukikibia huko kwa error, it has an error of 11164. Then you can see 45.
Yes.
What has happened for us to move from 45 to, or rather from 51 to 45, we have subtracted 6.
Yes.
So if these values of the errors are depending, we also expect now the value of the error here to be smaller. When we get there, we find 108. Naona hiyo 108.
Yes.
So hata hiyo yenyewe imekuja chini na around 3. So it's like there is a capacity. Naona hivyo. This one imeteremka inayo ikafanya nini?
Ateremka.
So it's like they are depending. But as I told you earlier, you don't just do one and get satisfied. You do several. So we go to the third one. The third one is 51. So what has happened? Tumeongeza another 6. So we expect sasa tukienda hata hii error itakuwa imesonga juu. It will have increased. But when we get there, we find 81. So you find it is like now this one has gone down by almost a whole 27. Can you see that error has been violated? Or that part has been violated?
Yes.
And also you can see this 51 is the same as this one. And if the errors are depending on the value of x, then these two values, they should have the same error, which is not the case. And you can go checking with the others that way. So if we are okay with that, in our notes that using visual inspection method, it is clear that error terms or error values are not depending on x values. It's clear they are not depending on x values. You can see they are not depending. Okay. So the fourth test is called normality. Normality assumption. Normality assumption. Maybe I needed to have added something here so that I'm able to connect to this one. Variance not constant. Variance, hence, not constant. They're not depending, it means that the variance is not constant. Okay. So this one, what happens? There are two ways of dealing with it. The first way is what I had said earlier, you draw polygon curve, you check whether it takes the shape of a normal curve. A normal curve, we know it looks like this, divisible into two equal areas. So just plot a curve, and then you decide whether it occurs normal or not. So our case, we shall not draw. The second way of testing this assumption is computing the mean and the variance. Because we know anything that is normal has a mean of 0 and a variance of 1. The variance of 1. The variance of 1. Somewhere we have made an error. This data is homoscedastic. Sorry. Able to delete this note. Should have read variance hence constant. Because they are not dependent, so the variance is constant. Change that, sorry for that. Variance is constant. We normally call it homoscedastic data. Homoscedastic. When we check, we are going to see that. So, with that now, takuja hapa tuseme the error values have a mean of 0, a mean of 0, a mean of 0, and a variance of 1, and a variance of 1, hence normal. When the variance is constant, we normally say it is equal to 1. It's not changing. And because we said here, it can be taken as 0, and this one we are saying is constant, then that satisfies the characters of a normal probability distribution. So we got that our error terms, they follow a normal probability distribution. Assumption number 5 is called autocorrelation. Autocorrelation assumption. What this means is that the values of y are independent of each other. The values of y are independent of each other. They are not influencing each other. If they are influencing each other, we say there is autocorrelation. Autocorrelation is where, when you know a few of them, you can tell the others. I want us to go back to the table. If you go there, you find the first value of y is 960. The second value of y is 930. So what has happened is that we have subtracted 30. So if this is the pattern, that unaenda to subtract 30, the next value should be 900, the next value should be 870. As in, when you know one or two, you can tell the others. But now, when you look at the actual results, you find this is not 900, it is actually 930. This is not 870, but it is 885. It's 885. So that tells you that the values are not dependent on each other. But this one, we also have a measure we call Durbin-Watson statistic. So we are going to have value here. And Durbin-Watson statistic is computed as 2 brackets 1 minus r. 1 minus r. So this one will be 2 brackets 1 minus 0.51. And I'm getting 0.98. 0.98. So when you get that, you now interpret that value. Now interpret that. So you say meaning. So the meaning of that is there is no autocorrelation between the values of electricity expenses, between the values of electricity expenses. Why are we saying so? This is because the calculated DWS into brackets 0.98 is in the range of 0 to 4. Look at the notes, you'll find that we normally recommend that it should be in the range of 0 to 4. So if you compute DWS and it's found to be within that range, then we are good to go. Finally, we have the sixth assumption. Sixth assumption is called multicollinearity assumption. Multicollinearity assumption. Now, this multicollinearity assumption, it is used where we have more than one independent variables. So in our case here, we cannot use it because we only had one independent variable, machine hours. And it says that if you have more than one independent variables, they do not affect each other. And I want to refer you to a question that we have in the past papers so that we make a conclusion on that. The question that we solved the other day, December 2004, questions 1. You refer to that question of December 2004, question 1. Are you there?
Almost. Yes.
Ukiangalia huko mwisho before the required, there is something written correlation matrix. From page towards the end of that question.
Yes.
If you look at that correlation matrix, you can see you can see minus 0.087, those are the two values for the production and the edicts. So the correlation coefficient between production and edict is minus 0.087. So we can make a comment on that and say there is no collinearity between production and index. There is no collinearity. That is, they are not influencing each other. They are not influencing each other. That is, they are not influencing each other. Why are we saying so? This is because the correlation coefficients, between them, you can put it in brackets, minus 0.087 is below the minimum of 0.8. So if you find that the correlation coefficient between them is below 0.8, that means they are not influencing each other. But if you put at 0.8 or 80%, they are influencing. So you will see the notes, and that will be good. So that is about the test for reliability. We call it a lesson at that point. Are you okay with that?
Yeah, I'm okay.
Good. Tomorrow, how is your day? Can we be able to squeeze 2 hours?
At what time?
The morning hours. Between 8 and 1.
Between 8?
Between
We can do it at 10.
We can do it at 10.
10. Yeah.
Okay. Sawa. I hope
Okay.
I remember. I hope you also remember now that it's not in the timetable.
Yeah.
Yona nimesahau kutumia link kunikumbushe. So that
Yeah.
cover the lesson we lost on Monday. Eh?
Okay.
So on Monday we were supposed to have a lesson.
Yeah.
Thank you so much.